Thank you, everybody who managed to find the room. I know you're very dedicated to have made it through the maze of downstairs. So I'm going to start by talking a little bit about what led to the creation of OSGP. Why does it exist? When we think about what conditions are in the smart grid or what led to OSGP, there's really three forces that we saw at work. One was the idea that the smart grid is more than just smart meters. Smart meters, of course, are a very important part of the smart grid, and often they're the first class of device deployed within a smart grid. But they're not the totality of devices the utility owns that are on the low-volt distribution network. And there is value in having intelligence across all those devices and having a protocol that can span all of those devices so that they can share infrastructure, which reduces cost, so that they can network together to share information, which opens up new applications. So one was we saw this need for a standard for an application protocol that spanned applications, that supported smart meters but supported more than just smart meters. The second thing we saw was that did a survey of existing standards and technologies that were out there. Not only did they tend to be very application focused, so it didn't have that breadth of application, many of them also started 30, 40 years ago in a world that wasn't a networked world. The design center of those protocols was really about point-to-point connections, maybe initially over an optical port, maybe later over a telephone port, but there wasn't this idea of a distributed network environment from the very beginning. And I think that leads to different design choices. There's different ways you approach a problem if your problem you're trying to solve is a networked problem as opposed to a point-to-point problem. So we saw there was some missing holes there. And then the third was as you're building a network, again, if a network is your focus as opposed to an optical port or a point-to-point connection, there's different things you think about in terms of efficiency, reliability, scalability. How do you enable multiple devices to share a common infrastructure efficiently? And so when we look at those three different aspects, we saw that there was a gap, and that is the gap that OSGP was designed to fill. Was to be something that was designed to span across smart meters and other smart grid devices, to work in a networked world kind of from the beginning, and to be very reliable, scalable, and efficient. This is just kind of reiterating that idea that OSGP is not just about smart meters. Smart meters are a very important part of the smart grid, but again, they're not all of the smart grid. And what you see here are some sample devices, and I'd invite you to go down to the OSGP stand at Metering Europe. We'd hoped to bring some of the devices up here, but they were already efficiently mounted into the stand, so you'll have to see them there instead. But what you see here is some meters from various providers, so 3 different meter providers, some different devices from other providers to connect into other smart grid devices. But what's important about this is that they can all live within the same infrastructure. So they can be part of the same system, they can live within the same segment of a network even, all sharing information with each other, sharing the bandwidth of the protocol, sharing in the security scheme, so that they can all work together cooperatively. You think about OSGP, so it's beyond smart meters, right? Smart meters and more, but also this idea of being highly efficient and scalable and work well in a networked environment. Today, we're in a networked world. We're deploying smart meters. We're building out the beginnings of smart grid networks, laying a platform where we can add other smart grid devices. And one challenge as we do that, as we see utilities looking to gather more and more information from these systems, is that places more and more requirements on the underlying network to be able to deliver that data efficiently and reliably. And so you see a lot of volume of data going back and forth across the network. What we've done with OSGP is design a protocol that is very efficient so that it can deliver the volumes of data that utilities are requiring today. There's no new technology that needs to be invented. And that's very important because obviously you're deploying systems today. Of course, you'd be deploying them 5 years from now as well. So you want a system that can expand, that has headroom. But you want something that works today that can provide you the growth path over time. And so all the things that I'll talk about later in the deeper technical session are really about how can we get very efficient use of bandwidth? How can we make a very efficient network so that we can deliver the performance that people need today without needing to wait until we invent new technologies to solve those problems. It's really important to provide the headroom to grow, right? So maybe you're doing daily billing today, you want to move to hourly profiles, to 15-minute profiles, to multiple devices. you need a network that can expand and handle that growth. Security and privacy are two very important aspects of the smart grid, so it's both authentication and encryption. Both of those are inherent to OSGP. It's not an option that manufacturers can choose which level of security, if any, they want to provide. Every device has authentication. Every device has encryption, period. It's just a requirement of the underlying protocol. Later in the afternoon, we'll be showing interoperability because, of course, the smart grid is being built out over time, and there's legacy standards you have, new technologies being integrated. So this idea of being able to interoperate across different standards is very important, and also something that's important within OSGP. OSGP itself, the standard or the specification, is published by ETSI. One of the questions was, how does ESNA relate to IEC, or how does it relate to other things? OSGP itself is published by ETSI. ETSI is the European Telecommunications Standards Institute. So it's one of the three standards bodies within Europe, where there's ETSI, CEN, and CENELEC. ETSI historically has focused in IT and telecom type specs, the ICT world, which of course is, we think, a good place for something like OSGP, which is an ICT networking standard. One very interesting aspect of ETSI is most standards bodies, when they publish open standards, you still have to buy the standard from the standards body. That's partly how they fund their operations, where they have to have revenue coming in to fund their work. That revenue comes from members that are joining, or that revenue comes from standards that they're selling. ETSI's funding model is slightly different. It's actually funded by the members and by participation in meetings. So non-members can participate in standards activities by paying a fee. But the standards themselves, the specifications that they publish, are actually free. And so you can download OSGP for free from the ETSI website. You don't need to be a member. You don't need to pay a fee. You don't need to sign an agreement. It is a truly open, freely available specification. If you go to the ETSI webpage, you can find it. Or if you go to the ESNA webpage, you can find it. If you look on Wikipedia, there's links to it. So it's very easy to find and download and access and evaluate. So then what OSGP is, and what we'll be talking about, the bulk of the remaining part of this presentation, after I introduce you briefly to ESNA, is what is OSGP. And so OSGP is actually a set of standards. So there's an application layer standard at the top. It's called ETSI GS OSG 001, which we just affectionately call OSGP for short, because the other is quite a mouthful. That's the application layer. It's media independent. It describes the model for smart grid devices, and I'll talk about that in a bit. It itself is built on top of ISO IEC 14908.1. 14908.1 is a general purpose control networking protocol, so that one's published by IEC. You do have to pay a fee to download it because IEC sells their standards. It's an ISO standard designed to be, again, media independent, application independent control networking. And so what it's really designed to do is provide very efficient transport and reliability services for control and telemetry applications, which is why we built OSGP on top of it, to leverage the services that that standard provides. And then the last part of OSGP, the last layer in the stack, right, is the physical layer. And OSGP, again, is designed to be media independent, so it can run over multiple physical layers. But initially, ETSI has published one, and ESNA is supporting one layer, which is ETSI TS 103908, which is an A-band power line networking standard designed to provide very high performance operating in the CENELEC A-band. But again, it's open to future media as well. And then all of OSGP are supported and promoted by ESNA. The other thing that we are announcing at Metering Europe and demonstrating on our stand at the show is interoperability between OSGP and DLMS COSIM. And this is a question that comes up quite a bit, especially in Europe and to a lesser extent in Asia, which is DLMS COSIM is an application model for smart meters. So it's designed for energy devices, not for other types of devices. Pretty broadly used within the commercial and industrial space, also some within the residential space. And one question that people have is if they want DLMS COSIM as an application model, many people believe they had to make a choice, which is if I want DLMS COSIM as an application model, therefore I must have DLMS built into my meters, because that's the only way I can gain access to COSIM. It turns out that's not the case, and that's what we'll be demonstrating and showing, that you can have DLMS COSIM as the smart meter model while having OSGP as the underlying device networking protocol. And that gives you the benefits of both worlds. So you have OSGP, which is designed to be highly efficient, scalable, and reliable as an underlying device networking layer. You can have DLMS COSIM as your smart meter application model. But of course, OSGP supports more than just smart meters. So you can have them in the same network. You, of course, wouldn't use DLMS COSIM to talk to those other devices because DLMS COSIM doesn't support those other types of devices. But they can all be in the same network. So you can have a DLMS COSIM view into your smart meters and whatever other view you want into other smart grid devices, all within the same network. So you're not forced to make an either-or choice. You can actually have the best of both worlds.